morning everyone. I am Mahima Saxena, Assistant Professor of Computer Science Engineering in AKGEC College. Today I'm going to present some topic on Introduction to Machine Learning. My first topic is what is machine learning? Basically, machine learning is a subset of AI which enables the machine to automatically learn from data, improve performance from past experiences, and make prediction. Machine learning contains a data set of algorithms that work on a huge amount of data. Data is fed to those algorithms to train them, and on the basis of training, they build the model and perform some specific task. Basically, in machine learning, we fed some data to algorithms, and then algorithm will learn from that data and perform some output. And on the basis of output, we analyze the accuracy of that algorithm. It's a subset of artificial intelligence which focus on using statistical techniques to build intelligent computer system, learn from available data set. A machine learning system learns from historical data, build the prediction model, and when it receives new data, it predicts the output for it. The accuracy of predicted output depends on the amount of data, as the huge amount data helps to build a better model which predicts the output more accurately. Suppose we have a complex problem where we need to perform some predictions. So instead of writing code for it, we just need to put some data extra to find the output of that algorithm. With the help of these algorithm, machine build some output. Basically, the lots of data we use, the more data we use, the output will be get better and better. Features of machine learning. Machine learning uses data to deduct various patterns in a given data set. When we give data to algorithm, the algorithm try to find some patterns or some data according to which it will learn, and it will perform some experiments and some steps to improve that data. It can learn from past data and improve automatically. It is data driven technology. Machine learning is much similar to data mining, as it also deals with the huge amount of data. Machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. So basically, in artificial intelligence, we use to mimic human brain. In machine learning, we use algorithms, and in deep learning, we use complex neural networks to perform our functions. These are the hierarchy. Need for machine learning. The need for machine learning is increased day by day. The reason behind the need for machine learning is that it is capable of doing tasks that are too complex for a person to implement directly. As a human, we have some limitations and we cannot access the huge amount of data manually. So for this, we need some computer system, and here comes the machine to take things easy for us. Basically, in these point, we are trying to say that human is incapable to learn from large data set, but machine is capable from learning large amount of data set. That's why we need machine learning, because it can handle large amount of data. We can train more machine learning algorithms by providing them the huge amount of data and let them explore the data, construct the models, and predict the required output automatically. We train machine learning algorithm. First, we give the training data set to machine learning algorithms. They try to find out some patterns and some points, and then they will predict some output, and then we will confirm it. The performance of the machine learning algorithm depends upon the amount of data. It can be determined by the cost function. With the help of machine learning, we can save both money and time. The large amount of data we use, there's much possibility to get better accuracy, to get better outcome. If we use a small amount of data, then the machine learn from it, and then if after that we use that algorithm on a large data set, then the algorithm will fails to predict. That is why we need large amount of data. Types of machine learning. We have three types of machine learning: supervised, unsupervised, and reinforcement. In supervised machine learning, we use labeled dataset. In unsupervised machine learning, we use unlabeled dataset. And in reinforcement learning, this reinforcement learning is basically based on reward system. In supervised learning, we have labeled dataset, and it is generally not for real time use, but supervised learning is for real time based. Supervised learning. Supervised learning is a type of machine learning method in which we provide some labeled dataset to the machine learning system in order to train, and on that basis it predicts the output. Basically, we have input and output, and we need to map from correct input to correct output. The system creates a model using labeled data to understand the dataset and learn from each data. Once the training and pre-processing are done, then we test the model by providing a simple data to check whether it's predicting the exact output or not. System create a model, label dataset creates a model to understand the data and pre-processing that data. Sometimes we need to pre-process the images, like we have a 2D image and we need to convert it into 3D image. This is called the pre-processing of data. And then after pre-processing the data, we predict the output with the help of training data set, with the help of testing data set. The goal of supervised learning is to map input data with the output of the data. The supervised learning is based on the supervision, and it is same as when a students learn things in the supervision of a teacher. The example of supervised learning is spam filtering. In spam filtering, we have first we provide some data set, the emails that have spam, and after that we use some extra data for testing the spam filtering method. Supervised learning is further classified into two parts: classification and regression. In classification, we use categorical data, basically categories that are divided in categories like yes, no, male, female, true, false. These are the categories. It can be binary, or more than two classes, or more than three classes. In regression, the continuous data is used. Classification. The classification algorithm is a supervised technique that is used to identify the category of new observations on the basis of training data. In classification, a program learns from the given data set or observations and then classify new observations into a new class or group, such as yes, no, 0, 1, spam, not spam, cat, dog, etc. Classes can be called as target, labels, or categories. Regression. Regression is a method for understanding the relationship between the independent variables or features and dependent variables or outcomes. Outcome can be predicted once the relationship between the independent and dependent variable has to be estimated. Unsupervised learning. In unsupervised learning, we use unlabeled dataset. This is basically good for real-time word problems. Unsupervised machine learning is a learning method in which a machine learns without any supervision. We don't have any supervision. The training is provided to the machine with the set of data that is not labeled, classified, or categorized, and the algorithm needs to act on that data without any supervision. The goal of unsupervised learning is to reconstruct the input data into a new features or a group of objects with similar patterns or similar clusters. In supervised learning, we don't have a predetermined result. The machine tries to find out useful insights with the help of huge amount of data. It can be further classified into two categories of algorithm: clustering and association. In clustering, we divide the data set into clusters. Now, what is cluster? Clusters are a set of objects or set of elements or set of attributes that have similar properties. That similar properties are divided into specific clusters. Clusters is the task of dividing the population or data points in a number of groups such that data points in the same groups are more similar to other data points in the same group and dissimilar to the data points in other groups. It is basically a collection of objects on the basis of similarity and dissimilarity between them. Association rule. Association rule is a type of supervised learning technique that checks for the dependency of one data item on another data item and maps accordingly so that it can be more profitable. It tries to find some interesting relationship or associations between the variables of dataset. It is based on different rules to discover the interesting relationships between variables in the database. Basically, in association, the like for example, we buy something from Myntra or any website. The data that data is stored by the site, and after that, related to that particular product, some suggestions have given by the site that we need to buy this and we need to buy this. This is called association rule. All these sites was using machine learning algorithm to predict our data set, to predict our preferences. This is called association rule. The association rule is one of the very important concept of machine learning, and it is employed in market based analysis, web usage mining, continuous production. Here market based analysis is a technique used by the various retailers to discover the patterns or associations between them. We can understand it by the example of supermarket. In a supermarket, all the products are purchased together and are put together. Reinforcement learning. Reinforcement learning is a feedback based learning method in which a learning agent get a reward for each right action and get a penalty for each wrong action. The agent learns automatically with the feedback and performs it and improves its performances. In reinforcement learning, the agent interacts with the environment and explodes. The goal of an agent is to get the most reward points and to improve its performances. The robotic dog, which automatically learns the movement of his arms in his of his arm. This is an example of reinforcement learning. Basically, in reinforcement learning, the agent is learned from from feedback, and from if he get good feedback, then it will be considered as then it will be continue to predict their goal, and if not, then it will be not continues their goal. Applications of machine learning. There are lots of application of machine learning. Machine learning technologies now emerging very fastly. First application is image recognition. Image recognition is one of the most common application of machine learning. It is used to identify objects, person, places, digital images, etc. The popular use case of image recognition and face detection is automatic friend tagging suggestion. Feedback provides us a feature of auto friend tagging suggestion. Wherever we upload a photo, or whenever we upload a photo on our Facebook friends, then we automatically get a tagging suggestion with name. The technology behind this is machine learning's face detection and recognition algorithm. Second is speech recognition. While using Google, we get an option of search by voice. It comes under speech recognition, and it's a popular application of machine learning. Speech recognition is a process of converting voice instruction into text, and it is also known as speech to text or computer speech recognition. At present, machine learning algorithms are widely used by various applications of speech recognition. Google Assistant, Siri, Cortana, and Alexa are using speech recognition technology to follow the voice instruction. The third is traffic prediction. If we want to visit a new place, we take help of Google Maps, which shows us the correct path with the shortest route and predicts the traffic condition. It predicts the traffic condition such as whether traffic is cleared, slow moving, or heavily congested with the help of two ways: real-time location, real-time location of the vehicle from Google Maps, real-time location of the vehicle from Google Maps and sensors. Average time has taken on past days at the same time. Email spam and malware filtering. Whenever we receive a new email, it is filtered automatically as the important, normal, and spam. We always receive a important mail in our inbox with the important symbol and spam emails in our spam boxes. And the technology behind this is machine learning. Below are some filters used by Gmail: content filter, header filter, journal blacklist filter, rule-based filters, permission filters, online fraud deduction. Machine learning is making our online transactions safe and secure by deducting fraud transactions. Whenever we perform some online transactions, there may be various ways that our fraudulent transaction can take place, such as fake account, fake IDs, and steal money in the middle of a transaction. To deduct these, feed-forward neural network help us by checking whether it is a genuine transaction or a fraud transaction. In feed-forward neural network, we have some weights, some inputs. Weights and inputs are aligned together, and then we check. Basically, it's a neural network structure, and we check for it output. Now we have another topic, the find as algorithm. This algorithm is used for hypothesis. The find as algorithm, this is a basic concept learning algorithm in machine learning. The find as algorithm identify the hypothesis and the best 5 matches of all the positive cases. The find as algorithm considered only positive examples or positive cases. When the find as method fails to categorize observed positive training data, it start with the most particular hypothesis and generalize it. How does it work? The working of this algorithm is the process start with initializing H with the most specific hypothesis. Generally, it is the first positive example in the dataset. We check for each positive example. If the example is negative, we will move on to the next example, and if it is positive, then we will consider it for the next step. We can check if each attribute in the example is equal to the hypothesis value. If the value matches, then no changes are made. If the value does not match, then we will change it to question mark. This is called the question mark is called as journal hypothesis. We do this until we reach to the last positive example in the data set. Algorithm. Initialize H to the most specific hypothesis in capital H. Small h is the specific hypothesis, and specific hypothesis is denoted by phi. For example, for each positive training instances X, for each attribute constraints A in H, if the constraint A is satisfied by X, then do nothing else. Replace A in H by the most journal constraint that is satisfied by X. Output hypothesis H. This is the example. Today we need to consider this example. To understand this implementation, let us try to implement it to a smaller data set with a bunch of examples to decide if a person wants to go for a walk. The concept of this particular person will be on what day does a person likes to go on a walk. Basically, these are the 4 iterations. These are the 6 attributes: sky, air temperature, humidity, wind, water, forecast, enjoy sport. This is our target attribute. And according to this target attribute, we need to find out the hypothesis. Okay, so basically, we will start from H naught is equals to 5. We have 6 attributes. Sky, air temperature, humidity, wind, water, forecast. These are the 6 attributes. That's why we use 6 phi's. This is the most specific hypothesis. Now, for the first iteration, we have, yes, this algorithm is only considered positive examples. So now the second hypothesis is H1 is equals to sunny, warm, normal, strong, warm, and same. This is our first hypothesis. Because this is positive, we will consider it. Now, for second hypothesis, H2. Now, we will compare basically H1 and second iteration. We will consider this and second iteration. The Sunny and Sunny is same, so we will copy it. Because in previous slide, if the constraint A is satisfied by X, then do nothing. That means the hypothesis and the iteration is same. That's why we don't need to do nothing. Else, replace A in H by the next most general constraint that is satisfied by X. Now in H2, Sunny is same, warm, same, normal and high. Now these are not same. That's why we will replace it with question mark. Then next step is strong, warm, same and same. This is our second hypothesis. Now for third hypothesis, what will we do? This is the negative example, and the drawback of find S algorithm is that it will only consider positive example. It will not consider negative examples. It will ignore it. So now H2 is equals to H3. H2 is equals to H3. That's it. Now the fourth iteration. H4 is equals to Sunny. Now we will compare. We will equal it. H2 and H3 are equal. Now we will compare H2 and H4. Sunny and Sunny same. Warm. High and question mark. We will always prefer question mark. If we need to compare between an attribute or a question mark, then the highest preference is question mark. We always consider question mark. This is strong and strong. Cool and warm, not match, question mark. Change and same, not match, question mark. Now this is our most specific hypothesis that we get from find S algorithm. This is the example solved. Same, we need to consider this. We need to compare this. Sunny, warm, normal, strong, warm, same. The H1 will be always same because our H0 hypothesis is the most specific hypothesis. We accept everything because we have nothing. Phi is basically null, so we have nothing, and we will compare it, and we got the exact same hypothesis. Then in the next case, we will compare sunny, warm. Normal and high are not different. That's why we use question mark. Strong, same as it is. Warm and warm are same. Then as it is. Same and same are same. Then as it is. After that, the third iteration is negative example, so we will not consider it, we will ignore it. And then we will compare this sunny and sunny same, then as it is sunny. Warm, same as it is. Question mark and high, always prefer question mark. Strong, same. Warm and cool, not same, replace it with question mark. Same and change, not same, replace it with question mark. This is the most general hypothesis. Find S algorithm is always find the most general hypothesis. Thank you.